Recording started. Okay, welcome everyone to what promises to be one of the most fascinating conversations we've had so far, and probably the most well attended, which is so beautiful to see here in the Hive. We called it from tree to tech: biomimicry and the future of materials with Andrés Mitnik. I'll tell you a little bit about Andrés, but before I tell you that, I'm gonna just welcome Andrés in our native tongue. Qué bueno tenerte aquí y bienvenido a esta charla acá en el AskNature Hive.
Muchas gracias, Camilo. It's a pleasure being here and having the chance to show what we do to such a group of amazing people. So thanks a lot for the invitation.
Anytime, and we're so happy also that you've had great experiences with the Ray of Hope Accelerator, and that happens to be also because of people like Maylise, like Sarah, and of course our newest member of the team, Raven, who also happens to be here. So very excited that you all are here. I'm going to tell you a little bit about Andrés Mitnik. This is the biography part of the conversation. Andrés Mitnik is the CEO and co-founder of Strong by Form, a pioneering company in advanced timber composite technology. With a background in civil engineering, Ingeniería Civil, he holds a master's in economics from Harvard University and a master's in urban planning from NYU, New York University. Andrés has worked across 5 continents, blending technical expertise with strategic vision, and more importantly, before founding Strong by Form, he was serving as a consultant in New York City and helped scale hundreds of startups as director of corporate venturing at Fundación Chile. Passionate about sustainability, Andrés leverages technology and collaboration to redefine materials in the built environment. Without further ado, te voy a preguntar la primera, which is, how did you first get interested in this very specific word called biomimicry? And what was your journey like to creating something of your own, which is Strong by Form?
Totally. Well, thanks, Camilo, for that very kind introduction. First of all, Strong by Form is not me only. It's a big team, but we're 3 co-founders. So whenever I tell the story, it's a combination of our collective work. Actually, we have a company where we manage our investments, and that's called Collective Brain, and that's because we are very complementary to each other. And everything came out from the fact that the 3 of us are very passionate about sustainability. But Jorge, which is one of my co-founders, he got very obsessed with what are the drivers of sustainability. And that has permeated to being like the core values of Strong by Form, where for us, first and foremost, is material efficiency. So whatever you're using, whatever type of material you're using, if you use less, it's better than if you use more. Secondly, reusability. And only in a third place, we think in recyclability. Our technology complies with all 3. But for us, the starting point is efficiency, material efficiency, and that's where when biomimicry came into play, basically because as probably everyone knows here, everything that's in nature is highly optimized. Because in nature we know that it's the rule of like the one that can adjust better will survive, and in that regard. In our case, trees are amazing structures, and they are super optimized. They consume as little resources they can, but to create something that is as stiff and as strong as possible to be able to deal with loads from the wind, deal with loads from the snow, but also using very few resources, because trees, as any natural entity, are competing among other plants, and they need to be efficient in the way they use resources. And this is very in tandem with the world of advanced composites, because the latest trends there talk about shape optimization and fiber alignment. And those are 2 concepts that are present in a tree. The wood in the shape of a tree is stronger than steel per unit of weight when you work in tension. But there's nothing more different than a tree, the products that we create out of it. A board or a plank, they look nothing like a tree. And just for for the general knowledge, the tree uses shape, and you'll never see a straight line in a tree because curves, double curvatures add stiffness without requiring more mass. And secondly, the tree aligns its fibers to map the way the stresses flow. And in that way, it ensures that every particle of wood is serving a structural purpose. There's very little filling, which is in sharp contrast as we humans tend to build, where most of the mass of the materials that we use are a filling material and not really serving a structural purpose. And was in that exactly in that space where Jorge was so obsessed about how to create the structure that would support a load using the minimum amount of material when he started looking at biomimicry as an inspiration on how to do this. And then he started actually with carbon fiber, but then the jump was how to get from there to the world of natural fibers, because we have a full sustainability roadmap, and carbon fiber is not very sustainable. But the beauty is that it's like we have invented things, but there's some things we do not need to invent. And I guess everyone that is into biomimicry knows this. But why invent the wheel again if nature has already invented it? It's tricky to copy nature too, though, and that's I guess that can be part of another part of the conversation. Like the best 3D printing in the world for wood is a tree, no questions about it, and that's because a tree is an amazing entity. And being able to achieve what nature does in such what seems an easy manner is not easy, and I guess that's one of the challenges of biomimicry. But basically we started with biomimicry because we thought that the most optimized structures are in nature, and that goes all the way from a leaf to a tree.
I think that that's like a great way to start the conversation, because when you think of it, a lot of us very like human oriented technology people, we think of our phones, we think of steel, we think of all these other materials that are either synthetic or that we create, and we don't realize, as you're saying, that nature itself, with the blueprint of the DNA from the tree and just how it creates everything, there's nothing that can ever compare. There's nothing that a lab can create in terms of what can be created by already a tree. And it's a creative act, right? So the beauty of that is, I think that when you think of strong by form, it's truly collaborative. And nature is so. Trees are extremely collaborative. So the question that I have for you as a segue would be, how does collaboration and research in so many interdisciplinary ways influence that creative process? Because the beauty of biomimicry, of course, there's tree, and you can very much understand the genus, the species, and all of these things we can find in an encyclopedia or a biology one-on-one or botany one-on-one. What did you learn from nature? Why is it that it's so cool that you decided to look at the tree in such a way with your colleagues?
I mean, there's a lot of space for collaboration there. First, we so the basic principle of our technology is basically mimicking the optimization process, the structural optimization process of a tree. But that doesn't end there. We did a canopy that is now placed in a train station in Berlin. And the inspiration for that was actually leaves of tropical plants that actually, it's great because the ribs are shaped in such a manner that they're super efficient and they can achieve these very long spans, we only being supported on one side. And we have found a community of researchers that are working on these studies and on these designs. And of course, we feed from there. But then a huge area where we collaborate is the fact that to be able to copy nature, at least the way we do it, it's like it's a multivariable process. So we need to bring together areas all the way from material science to digital optimization, to advanced manufacturing, to sort of the latest pressing process and chemistry, to be able to imitate this process. And of course, we are a startup, and even though we're 30 people already, which is pretty big, I would say, especially for our stage.
Startups, and it's like, I'm sorry to say that, but that's just incredible to know that like in these few years you've been able to like sustain a business that happens to be biomimetic and also have a staff of 30, not contractors, staff of 30. That's pretty impressive. So little segue, a little parentheses, keep going, sorry.
Thank you, thank you. But even though we're that many, there are many areas that we do not have expertise and that we need to be able to do this. Chemistry is specifically one of them. So we collaborate with companies like Henkel and with Yowatt to learn what's about their latest chemistry. How can this chemistry be greener? We also collaborate with scientists that are outside the corporate sector to find what are they dreaming about and what is it really possible. Because there's some areas, and I would say specifically in chemistry, that the new tendencies will actually become probably a threat to the old chemistry. So you need to like source from many different places to be able to know where things are going, what's available right now, and what might be upcoming. Then how we build this, we're building a 10-meter long structural floor, which is the first prototype of such a big entity. And because our technology is quite flexible, we have sort of two different manufacturing principles to achieve similar results, but with different characteristics, I would say. And we don't have all those characteristics. So we are working with Fraunhofer in Germany, and they are helping us build this again. When we did Ray of Hope, we learned about mycelium, and mycelium has anti-flame characteristics. And for example, fire for us is a huge topic. We're not experts in fire safety or in fire retardants, and finding an alternative in mycelium that is actually a natural product that it combines well with our offer sounds amazing. And also, at the end of the day, and I think this is probably true for many here, we're in the world of the built environment, and trying to contribute to make the green environment better is not a silver bullet. It's going to need a combination of multiple entities and multiple people working together. If we would stand ourselves and say like, hey, we have this technology for construction, we're going to disrupt construction, don't ask anyone else, now all buildings are going to be made out of Woodflow. First of all, it's not possible. And secondly, that's a project that will get nowhere because there's no way we can compete with established players. We're not going to change the world ourselves. We're creating a tool that can have a huge impact. But for that deep impact to be realized, cooperation is totally and definitely needed. And I would guess the same as nature, we of course start speaking with people that have a DNA closer than us. But the idea is to spread those genes and then make it like come to the bigger public.
I think that makes total sense. And when I think of just the material strength, flexibility, and resilience in both the technology that you've created, but also biomimetically in the company you're creating, that's the beauty of what you're doing, right? It's adapting all of these biological models into the thinking behind the business and also how you align yourself with corporations, right? It's not like when there's a eucalyptus tree that might be very specifically hoarding a lot of water that you're going to disregard the eucalyptus tree because it's adapting to do so. You're a redwood. Okay, redwood is connected. It's two different species. It just happens to be adapted to different things. So one question that I have for you is, when you think of Woodflow, which is this proprietary technology that you've been developing, can you share more about how you make it, and do you happen to have an example of it?
Sure. Yeah. I mean, Woodflow is what you can see in the ceiling of this train that is on the back of my background, and that's only one of the use cases. So another thing that we have learned is that when you develop a technology that is, at least in our case, based in nature, it has many advantages that haven't been previously seen. Just to give you an example, Woodflow is the only composite we know about that can be deployed in the millions of square meters to serve as a construction material, while at the same time having the the weight to strength ratio required for industries like automotive. So there are few materials. Well, steel is another material that can do that trick, right? You can find steel in a building, and you can find steel in a car, but there are not many materials that do that trick. And the thing is that we are way lighter than steel, for example. But that means that you need to sort of to adapt and to be able to identify where is the highest growth, to be able to push this business, regardless of the fact that there can be multiple opportunities. But the beauty is that that's a happy problem. The not happy problem is having a single use case, and if that doesn't work, then you're done. And Woodflow looks like this. So this is our first product. Is more of it's a decorative product. It's not a structural one, which is the same road that multiple companies like us that are doing new construction materials go through. Basically, because decorative products need less certification, they can come quicker to the market. You can do basically have more flexibility while you finish the certification and the development of the real business, which is the structural ones. But the concept is the same. So here you can see this is a 3D piece of wood that is only 3 millimeters thick, and this can actually serve as a element for a decoration in a building, or can serve as a replacement for aluminum in an electric vehicle, because it's light, because it's thin, because it's very sturdy. It's quite strong because of the curvature and the design. So this can have multiple uses, and as you can see, we can use different finishing, different shapes, different colors. This is 90% wood, behaves like wood, but this 3D wood, which was part of the learnings that we had. At some point, we realized that 3D wood look amazing, and that's when we opened new product lines. And the way we manufacture these guys are, I would say, we have gone through a process that has been interesting on the sense that when we started, this was way more complex to build. So our original approach entailed using smaller flakes, entailed like a much detailed fiber alignment. And then at some point in time, while we started to domesticate the technology and while we started to test it and see it, we created something that you cannot see here because it's hidden, because it's part of our secret sauce. But basically, the composition of this is much simpler than before. Instead, and I'm just going to give you an example. Instead of breaking the wood into little pieces and then organizing little pieces, we realized that we could do something like this, which is wicking the wood in specific points where we know it will need to fail, so it fails in an organized manner. And that simplified the process and opened new use cases as well. And of course, you see this, and this looks like a piece of wood, but this is the result of a software. So the software is going to analyze how this needs to be formed and where these sort of lines or cuts need to go to be able to achieve the desired form. You can do this without software, but it's an iterative process, so it's not so efficient. And that is Woodflow. So what's Woodflow about? We use today a robotic manufacturing process. And we use robotics because of a couple of things. They're very well known in the world of advanced composites. A robot, to be honest, sounds like fancy technology, but as one of my co-founders says, like it's basically a printer that is like on steroids. But it's a piece of machine. It's a commodity at the end of the day. We even buy used robots. But the interesting thing about the robots is that they're very flexible. So our approach was, because we are doing a couple of new things. So we are using shape with wood, which is new. We're aligning wood fibers, which is new. We decided to use resin that was off the shelf, not because it is the cleanest one or the one we like the most, but it's a problem that has already been solved and it's not part of our critical path. And in our critical path was to find an efficient way on how to produce this. And that's why we started with a philosophy that was the most flexible. What we have right now installed in our lab, to be honest, is not optimized to produce any of the products that we have in the market at its sort of lower cost. It's like a jack of many trades. But that has been great because at this early stage, we're not in the business of actually creating blue numbers, but we're in the business of finding out how to do this in the best manner. And that's where the robotics play a role, because they're super flexible. So for example, now we have simplified, we were using 6-axis robots. Now we're using only 4-axis robots, because we realize that we don't need such a degree of flexibility. And for the structural elements, there's no robotics involved at all. That doesn't mean that it was a mistake to start with the robots, because the robots allow us to learn how we can not use them. So today everything looks very sophisticated, and it's robots, and it looks like, like this futuristic feature. But in our DNA, there is the passion for technology. It's not the passion for the tools. So we see it as a way of software. For us, for example, is key, because software is a way to scale things. We're in a world where everyone wants its own design, and go again and do consulting and help every single architect do a new design. It's not a scalable business. And we're not a consulting company. So we developed a software that translates very quickly what someone wants into design, so they can play with it. We have another software that takes those results and creates automatically the molds before someone had to translate, CAD designs into like another piece of software, so we can program the CNC machine. So we can streamline all that using the robotics, and that will work regardless of whether we use robots or not. And that's what we've been doing right now. Like for us, learning how to imitate nature has been a big challenge, even though the basics of the sort of the technological hypothesis have been very clear since day one, and we've been lucky enough that they were proven true. Doing this at scale, and like a forest grows at the same time, and it's amazing. The productivity is high. Imitate that is a big challenge, and that's the road we have followed to reach where we are right now.
It's something that you said earlier of like, we just don't need to reinvent the wheel, but also I think we all resonate in terms of a lot of the times we confuse the technology as indeed a tool, or like as fashioning something out of nature. And we're not the only species that have created technologies, right? So the beauty of that is, I think we're doing, with your example, what we do best when we think biomimetically, which is we're also learning from nature of how to use the tools we have fashioned already for ourselves, be it robotic, be it also wood, and using as much as we can in the most, I would say, aesthetically pleasing, functional, and sustainable way possible. So that's a beautiful thing. Everyone, I'm going to switch to Espanol for a second here. I'm going to ask the question in Espanol. Lily's going to post it in English on the chat so that you can also see what the heck is Camilo's talking about in Spanish. But then I will translate what Andrés tells me. I think, cuando me pongo yo a pensar, Andrés es una empresa pionera con raíces en Chile. Y si te pones a pensar, Strong by Form está liderando una innovación en materiales y es en el entorno construido. ¿Cuál es tu perspectiva sobre el potencial de América Latina, de Latinoamérica, para impulsar esas soluciones sostenibles y que transforman a la industria de la construcción a nivel global?
Mira, yo creo que en Latinoamérica y en otros lugares, como también creo que en la India, por ejemplo, es el caso, me ha tocado ver experiencia, tenemos una ventaja y una desventaja. Lo que se ve como una desventaja es que tenemos pocos recursos. No tenemos tanto financiamiento, no tenemos en el fondo universidades tan destacadas, etcétera, etcétera. Pero eso nos obliga a ser muy creativos. Y también está esta como tradición de como la Pachamama americana, y tenemos el Amazonas al lado, y el Amazonas es una fuente de conocimiento infinita en términos de lo que uno puede aprender de la naturaleza. Entonces, yo siento que esta es una geografía que está bastante en contacto con la naturaleza. Y la combinación de estar muy en contacto con ella y al mismo tiempo tener problemas para los cuales hay carencias que resolver, te obliga a ser imaginativo. Y ahí es donde esta combinación de inspirarse en la naturaleza funciona muy bien, porque en general la naturaleza ya resolvió estos temas. Entonces, en Latinoamérica yo veo que tenemos todas las capacidades para poder buscar más esto. Lo que creo que nos falta es que yo vivo en un mundo donde biomimicry es una palabra que se conoce. Eh, pero acá en Latinoamérica yo creo que hay muy poca gente que sabe de biomimicry, porque en realidad es una tendencia, o sea, toda la vida le hemos copiado a la naturaleza, pero estructurarla como un concepto y como una metodología y como una forma de hacer las cosas, al menos para mí, es relativamente nueva. Y eso es lo que yo creo que falta en Latinoamérica, porque inspiración, creatividad y naturaleza tenemos de sobra. Es sencillamente llamar a esto, porque lo otro que nos ocurre es que miramos mucho afuera eh, y no nos damos cuenta que tenemos muchas de las respuestas aquí adentro. Eh, Así que yo te prometo que creo que en el fondo esto es posible. La complejidad es que muchas veces las soluciones biomiméticas tienen un nivel de sofisticación que tampoco aplican inmediatamente a los países que no son más desarrollados. Entonces también hay un puente que hacer súper importante. Para nosotros no es posible hacer este proyecto si nosotros pensáramos que Chile es nuestro mercado. Entonces tuvimos que nacer conectados con Europa. Y por eso después hicimos Ray of Hope, porque necesitábamos la conexión con Estados Unidos. Pero si uno logra poner esas piezas del puzzle juntas, están todas las capacidades para hacerlo.
Let me just finish 1 second writing down the last point, and I'm going to read it out because, of course, not everyone should be reading all of the stuff I just translated. So give me 1 sec, which is like Ray of Hope will Okay, as you saw, I was doing this in real time. It takes me a second. Beautiful. So I'm going to translate all the good stuff that Andrés just answered to me in Espanol in his beautiful Chilean accent, which I'm so happy we get to speak Andean Spanish. Oh my God. Okay, Andrés says, I think that Latin America and other places like India have both an advantage and a disadvantage. We have few resources, but limitations brings us what we could consider as creativity. Pachamama, which is, of course, one of the ways in which indigenous peoples in the Andes have called Mother Earth, and our geography in Latin America is always in contact and connected to nature. We have to use this connection and these limitations to be creative. Nature already solved these issues. Latin America doesn't know much about biomimicry as a term, as a philosophy, or as a concept. It is something that's missing, that connection to that linguistic vehicle that is the term of biomimicry. And inspiration, creativity, nature, Latin America has it, but we also have to keep looking to the US and to Europe for resources, for opportunities that might bridge some of those technical vehicles that we need. But we got lots in Latin America to already use as a source. And biomimicry is sophisticated, and sometimes there's a bridge to build with regards to bringing up solutions that have those resources. Or that need those resources from other places. So I think pieces of the puzzle, like the Ray of Hope Accelerator, will continue potentiating solutions like strong bioforms from Latin America. That is true. And I'm so happy to know that Ray of Hope this year is potentiating a couple of others, or if I'm not mistaken, at least one from Latin America and specifically South America this year. Before we go into the Q&A, which I want to leave enough time for everyone to be able to ask questions, I saw that there's a couple on the chat, so I'll go back and start asking that one. Lily, do you mind if we take a little screenshot of everyone? If people are okay with this, it would be lovely because there's a few faces that I'm seeing. Come out in your camera if you can. I think it's a lovely opportunity to just see all of our faces connected throughout different places of the world. And then we can take a little screenshot that can make us remember what a beautiful conversation this has been, especially because you're about to be the ones asking questions directly to Andrés. 3, 2, 1. Actually, Lily, let's do it again because I think a couple more people are coming out. Okay, let's see. Let's give people 5 more seconds to come into camera if possible. 5 seconds, 4 seconds. All right. Take it whenever you want, Lily. Beautiful. Thanks so much, everyone. That was lovely. You can stay. I think I'm very happy seeing all your faces. I also understand in the world that we live in, that it's also kind of nice to not necessarily be on camera all the time. So it's perfectly reasonable. Let me start then with that first question that I saw earlier on the chat. Give me one sec. I think it was by Edwin Marie Garcia La Torre, if I'm not mistaken, also in San Francisco. So that's great. And you can come out and say it if you want. I can also just read it. I'm perfectly fine with that. Whatever you prefer.
Sure, I can speak. Hi.
You got
I'm in Oakland too. It's just I work in San Francisco, live in Oakland. So
what's up, Bay Area?
woo!
All right. Go.
Background, I am from Puerto Rico, so I'm a Latin myself. So I'm really proud of hearing all this in Spanish as well. My questions to you, Andres, it's amazing research. I'm really curious about. I know you have a secret sauce, but I want to know if you're like looking into the alignments of the filaments in terms of any play on rotation based on either trees or other types of natural structures, as well as considering permeability or impermeability. Is that something that you're looking into or considering?
Sure, Edwin. Of course, permeability and impermeability and water resistance and fire resistance, those are all things you need to deal when you work with construction and with anything on the built environment. Just to give you an example, we have a project with BMW where we're trying to replace the metal in the body of the car, so in the exterior elements. And BMW explained to us a while ago that they manufacture the same car to be run in Abu Dhabi or to be run in Siberia. So these materials need to work basically in any environment. And that is especially challenging because there's, for example, one of the characteristics of what we do is that it's very thin, great, light, but has very little mass. So for today in the market, there's nothing that is thinner than made out of wood, of course, that is less than 12 millimeters, that is fire resistance. And we are creating the first thin shells that are going to be fire resistant made out of wood at this thickness. And that's a whole development that probably, no one faced this problem before. So chemistry and coatings and additives, it's a full agenda, and that's why we actually a few months ago we decided to beef up our material science team, because for us material science we realize it's a core ability that we need to have in house. Okay, and that was the second part of the question. Which was the first part?
The alignment of the filaments.
Oh,
If you're playing around of rotations, because I know it's trees are more unidirectional unless there's like a curve or a change in structure. But in other places like kite instruction tend to have a helicoidal rotation every 5 degrees. So it's really interesting to see if you're playing with that.
No, totally. So no, we do not. I mean, we can do helicoidal, but we really don't need it. What we do is basically that we have a shape. The first thing we do, our software, when we create a component, is that we have the stress points, right? We know the support points, and so we're able to have those are our boundary conditions. Once we have the loads and the sort of boundary conditions, our software first creates the shape that will resist the load using the minimum amount of material. And that goes through, it can be, we can take it to different levels of sophistication. We can do it on a single thickness. We can do it on a variable thickness. And then there are more manufacturing considerations on how sophisticated we do it or not, or performance-wise. And once we have the shape, we model how the stresses will flow through this shape. And when we have that model, we use a process that's called tessellation, where we transform those vectors into discrete vectors, and then we align the wood fibers to follow that stress map in a way that is not exactly the same, because these flakes are basically rectangles, so they're not curvy flakes. But when you put them one on top of the other, you start making the shape. And that's the way we align it. And of course, the trick is how to align these flakes in bulk at a productivity level that makes sense to the market, and it's not like a piece of art that is super expensive and no one can really buy it. But the art here is in more on how to do it than on what we do.
That's a good approach. Y gracias por la pregunta. And I think that one of the interesting things that I keep thinking about compared to strong by or strong by form compared to other timber and other ways in which we've used wood is using the majority of the tree and also understanding all of these very important variables, chemical, physical, like all of these different forces to create a material integrity that actually is great for, as we were saying, vehicles, furniture, or even the environment. I think that that is fundamental here with Strong by Form. Feel free, if you can, raise your hand, or you can also just like come out from mute or post it on the chat. I, of course, have other questions if no one else has more questions, but I bet you do. So feel free to ask a question any of the two ways that I just described. I have one from Rashida. Do you want to say it? I can also read it. I'm perfectly fine with that. Let's see. I think I see it here. It says, curious to know which families of trees you are using. Are there particular types of trunks that are soft, flaky, hard, lenticles, and so on, and which are used? That is a great question. Before Andres goes, the Ray of Hope has created over the years some incredible animations. And some of these questions, if you are an educator, if you're a person that is just more visual, I just posted the link on the chat so that you can watch it later. Andres, so again, what are all these families of trees you're using? And what are all of these very different variables that you're taking into account and different kinds of structural characteristics that you're using?
Totally. So, linking into the question before, let me start by saying that we were not the first ones that had the idea that you can use shape and fiber alignment to make products out of wood that are going to be light and strong. What we are the first ones is to devise an industrial process on how to do so. And a couple of our advisors had this idea in the university. They tried to put it together in the 90s, and simply the technology wasn't there. So I'm just saying that because this is not only about having a genius idea, which is great if you have one, but execution is key in this kind of endeavors. And then it comes the fact of what type of wood we use. So first of all, the question was, we wanted to use natural fibers. That's what we wanted to use. We wanted to use a renewable material to replace non-renewable materials. And the world is full of natural fibers. There's hemp, there's bamboo, that is an amazing material, there's wood. But wood is the most widely available natural fiber at an industrial scale in the world. So basically, everywhere you go, there's a wood industry, which is not the case for bamboo or for hemp, which are great, but they're more bounded geographically. So that was one decision on why we use wood. And then we started to play with wood. And this came for me as a surprise, maybe for my co-founders not, but we are very agnostic to the type of wood. So we are working with local wood wherever we're manufacturing something. We can use hardwoods or we can use softwoods. That depends also for the use case. For construction, where the weight to strength ratio is relevant, but it's not as extreme as what you need in automotive, we basically use the cheapest, softest wood that we can obtain. And there, we try to use, and we use a very high percentage of the tree, but also we use low quality trees because they're cheaper and because there are not many alternative use to them. So for us, that's a business opportunity, being able to use second grade wood. For applications in automotive or in mobility, where the weight to strength is much more important, it needs to be really light, then we work with harder woods because those wood have better mechanical characteristics. And because our composite is 90% wood, we basically inherit all the characteristics of the natural wood that we're using. So for some use cases where we need to sort of be specific about the type of wood you use of wood, for others, we can be very agnostic. But then you run into other type of problems that are not technological problems, but regulatory problems. So for example, can we use recycled wood? Sure, as long as we can flake it, we can use it. But how do you certify something if the feedstock is not constant? Because the formulation needs to be always the same for the European Union or the US to give me certification saying, like, every time you see this, this is the way it will behave. And we haven't found, I mean, there's no supply chain around recycled wood that can ensure a constant feedstock. If that was the case, we could use it, and it would be even better. But today we can't, not because the technology cannot, but because like there's not an organizational setting or a regulatory setting that would allow us to do that.
That makes total sense. And I think that that's another aspect that always we're encountering, right? Like different conventions, different ways of, in many ways, laws. It's just like the legalistic aspect. It's always there. Before we go with Mark Dorfman, we're going to hear a comment from Mark Bowles, which is, I appreciate your integrity in acknowledging you are not the first and how you have shaped your distinct direction. I think that is very true. And that's the beauty, right? When it's biomimicry, it's not just, cool, let's go to nature, extract and figure stuff out to enrich ourselves. It better be also biomimetic, which means that it is also natural, and nature also acknowledges integrity and ethics. So that's always a good thing. Mark Dorfman, you can go. Thanks so much for being here. Lovely to have you here. I think you are muted, if I'm not mistaken, Mark. Sorry.
I unmuted and somehow it got muted again. Anyway, I was saying thanks, Andres, for your presentation. Really interesting and fascinating. So I'm just curious about the additives, the coatings, the composite materials that you use. Are they also bio-based? Are they biomimetic? Or have you had to use some more conventional additives to achieve the functionality you need?
Yeah, perfect. That's a very good question. And the short answer is that we are using synthetic materials to do that. But there are a few shades of gray in that space. First of all, this is something that I actually learned at the Ray of Hope retreat. Chemistry is something that can start from many multiple sources, like the basic element, the methane, and the basic elements of what build any chemical product can come from biosources. The problem is that that oil is so stable. It's great to work with. We know the oil chemistry for more than 100 years, so that's all well optimized, well known. It's hard to challenge that from the world of biochemistry, simply because biochemistry is newer and there's not so much knowledge inside. Stability, for example, is a huge topic. But things are there, and we have some actually, one of our investors own a chemical company, and we're testing their bioresins. But then again, you run into other type of restrictions. For example, if you want to certify a structural product for construction that is a composite, the resin needs to be certified for structural purposes as well. That's a fancy word to say that it would not dilute with water. But anyway, and today, at least in Europe, there's no bio-based resin that is certified for structural purposes. So if we want to hit the market soon, we need to do that trade-off, because we could engage in creating a resin that has structural capabilities and that is bio-based. But if we do that, we have to have a full research agenda, certify that first, and only then come and certify our product. And this is something that I sort of learned from a book that's called Build, by the guy that like invented the iPhone, I mean the iPod. That is that when you want to get into the market with a new product, go for the most basic one first. If it works, go for it and put it into the market, test it, start getting, customer feedback, get your first revenues. You will have all your life to improve the product. And that's sort of our strategy. We're not planning to live forever with this sort of synthetic adhesives and additives, but in the meantime, we need to live with them. we are trying to use them as green as they can. So, for example, we use a polyurethane, and today there's a bio-based polyurethane that is 50% bio-based. Okay, we try to do that, but we need to sort of, pick our battles. And in our space today, the battle is to come to the market and then to continue improving the product.
Totally. Mark, I see your hand up, and if you have a follow-up, absolutely go for it.
Yeah, well, I mean, this can be a long conversation, but I think it's true in a lot of biomimetic inventions that there are aspects of it that could still, need lingering improvement. And like you said, Andres, you could either wait and make it perfectly biomimetic, but be 15 years down the line. So, it makes sense to sort of prove your technology and then sort of be upfront and transparent that, hey, we're working on these other things. I had one other question, if I could ask that.
Yeah, if it's a short one, and then we can have
Yeah.
Melissa the last one. Absolutely, Mark.
So, you're talking about stiff materials, but plants also show us how to make flexible materials. So I'm just wondering if you are also doing or planning to do research where you can learn from plants to make flexible materials to replace even more of the conventional materials that we use.
Absolutely, and that's a huge question, and I'm going to sort of brainstorm up for a moment because I thought about this, but I haven't actually put it in words before. We started this company thinking that we developed this technology called Woodflow, and Woodflow is what I show you, right? These shells that are thin that use and I have this characteristic of being strong by combining shape and fiber architecture. But then, since day one, we also thought about how about wood bones? So copying the structure of bones using wood fibers to create another type of elements. And we also thought about wood nerves. And then how we can actually create flexible structures that would have another characteristics. And that's why we originally defined ourselves as a technology company, which we still define ourselves like that. We know that our edge is in developing technology, in testing it quickly, debugging it, and find use cases for it. Manufacture, in our case, needs to come on a licensing term or on a joint venture because the level of manufacturing that we need to have an impact, it's really big. And there are others that already know that. So again, collaboration, and again, like we're not inventing the wheel again. And that's why, and this is a full conversation, we have many corporate partners as investors in our company. But what has been the reality of that idea, of that dream? That the first technology, Woodflow, already has so many use cases and already so challenging to bring into the market that what was supposed to be a 3 or 4 year project has been 5 and it's going to be 10. And I think the next technology that we will develop, probably we will do it in 4 years from today, because just extracting the value of what we have already done is a huge endeavor. So we dream again, and perhaps if we grow and we can afford to have a bigger team, we could do more things in parallel. We have the inception and the idea to do so, but in reality, a startup needs to focus, and a startup needs to have specific products, and that's always a trade-off that you need to do on how much you push the science and you push what's possible against how much you use your resources to transform that knowledge into products that people actually buy.
Absolutely. I will have Melis finish us on this conversation. The last thing that I want to say is I really always appreciate Mark in the few interactions that we've had, just because, of course, you have so much of a wealth of knowledge. And I think that chemistry angle, or so many different things, is, I think it's always fascinating to look at how many more ways we can always think about the one technology. And that's the beauty of biomimicry. We can always learn different aspects of the same thing. Speaking of that, we have someone that actually happens to have knowledge in chemistry. Melis, go ahead.
Thanks, Camilo. Melis, the program manager of the Ray of Hope Accelerator. It's so great to have you here, Andres. And I think using the resources that you have is also learning from nature in the most efficient way. So I love this perspective. And you mentioned corporate partners, and you developed really strong, amazing corporate partners over the years. And open questions, is there anything that surprised you in building those partnerships?
Yeah, that's a good one. Yes, a couple of things surprised me. First, the serendipity of these things. Like I'm going to bring the topic of the BMW, which is not our focus, but I think it's a nice experience because we work with BMW, which, to be honest, is a tough one to capture. And we're from Chile, and startups from Germany ask me, like, how the hell you do this? And the way we did it was actually not trying to sell them anything. They welcomed us to an acceleration program, then they invited us to a mentorship program. We were trying to get the most out of it. We were visiting them, and suddenly it took like 2.5 years. We were at the right time, at the right moment, talking to the right person. And that has happened to us a few times in this process. So one thing that I have realized is that, like, this positive attitude and this attitude of collaboration is super relevant. I call it like non-structured interactions, because I spent a fair amount of my time, which is one of a limited resource, having conversations with people that I don't exactly know where these conversations are going to end. I know how they start, but I don't know where they're going to end. And I always try to have this attitude of, if I can do a favor, if I can open a door, if I can make a connection, I'll definitely do that. And I don't know if you can call that karma, but honestly, this is a network that you need to weave in a way that is not very predictable. And that has surprised me how well that has worked for us. Just to, and this is not to brag, but just for you to have an idea of what kind of interactions we have. We work with BMW, we work with Deutsche Bahn, we work with NS, which is the train operator for the Netherlands. We are working with Siemens, we are working with Alstom. We work with Vinci, which is the largest construction firm in the world. We work with Europe's leader in structural timber. Some of them are investors, some of them are partners, some of them do projects. But it's this collaborative setting that has helped us to germinate and to grow. And the other surprising thing is that these corporate guys like working with us, basically because it's fun. And like when you do biomimicry, it's not like, I mean, they realize that we're creating something that we're doing it for it has a good feeling, it has a good purpose. It's made for making good to the world. And that's an asset that needs to be levered. It's not like for example, defense. I have nothing, and I'm not going to judge anyone that is into defense, because defense is very hot. We have use cases in defense. We're trying not to push any defense agenda, basically because we do not want to lose our edge of being the nice guys and being the people that is fun to work with. We do not want a dark cloud on top of us, because I think that will affect our serendipity. Yeah, and I would say that has been really surprising.
That, I think, is such a fundamental thing. The other thing is, like, you couldn't try to be the bad guy, Andres. What are you talking about? So that's an important thing. I think, again, it's really looking at, we are doing good to our planet by reconnecting with it and knowing how to use what we have and learn from it. This has been really wonderful. In the interest of time, thank you all for staying a couple more minutes than what was scheduled. And really looking forward to having you in other conversations for the Hive and other events. Remember that we want to make this it's for us all, right? It's not like Camilo, the AskNature director, talking at you. I want you to be feeling like this is yours. And we want to keep fostering this biomimicry movement, as Janil, the head of programs, likes to say. And it's true. I think we can foster that here, especially having these kinds of interactions. Have a lovely rest of the day to you all. Some of you have a lovely night, and we'll see you around on the next one. Andrés, un placer.
Muchas gracias. Hey, thank you everyone for being here. It's a pleasure talking to you.
Bye, everyone. Thanks so much.
Bye.